Good evening, everyone. I'm Pudika Shivani from Tech for Autism and Dyslexia project. Currently in my second year, second semester, I will be presenting our progress and innovations under the TADMileStone project, where our team has focused on enhancing emotion recognition through various technical modules. Here's a quick overview of today's presentation. I'll walk you through 6 main tasks we have undertaken. First, face validation component, transformer building, updates on our main website, image capture integration in games, report generation, and patent filing. First task was to ensure high quality face data for emotion recognition. We built a real-time face validation system that checks for brightness, clarity, and proper framing before capturing images. This forms the foundation for accurate emotion analysis. We used navigator.mediadevices.getUserMedia for camera access. MediaPipe's face detector was integrated via TensorFlow.js. We computed brightness and shadows in real time using Canvas and gave live feedback to users, only allowing to capture when all the checks are passed. We faced issues like poor lighting or children not looking directly into the camera. Our solution? We introduced real-time shadow detection, gave dynamic feedback, and ensured only validated images are captured. These snippets show how we loaded the model, checked lighting, and allowed image capture when validations are passed, ensuring consistency and quality in every image. This is our total solutions web page where we have logged in as a therapist, and here we can have all children's names, and under you have play button. When you click on that, this page opens where it is checking for lighting, shadows, and face. So once everything is good, if the lighting is good, there's no shadows and face is completely appeared, all these will be checked and it will enable the continue button. So now everything is good and the continue button is enabled. But if there is a problem in the lightning or the face is not fully appeared, then it says no face, poor lightning or no face detected, and the button will be disabled. So when all the conditions are checked, it gives, when you click on continue, it will continue to the next game pages. Task that we have worked on is transformer building. We moved from traditional SVMs to transformer model for facial recognition. Transformers originally used in NPL are powerful due to their attention mechanism, which helps in understanding relationship between the features. So these are the factors that have that helped in choosing transformer over SVM. So transformer can handle large data sets. It can capture complex spatial temporal relationships where the SVM cannot. We can have a pre-trained model availability in transformers but not in SVM. Raw image input is supported by transformer and not by SVM. And generalization on unseen data is high for transformer when compared to SVM. Facial expression recognition using face mesh plus transformer. A transformer is a deep learning architecture based on self-attention. Unlike RNNs and LSTMs, it can process entire subsequence in parallel, capturing global dependencies. Originally designed for NLP, but now widely used in vision, speech, and structure data. So the reason using for face mesh and transform is that Face Mesh can extract 467 facial points from each face, offering rich spatial structure for expressions. And the transformer can process all 467 key points simultaneously, learning how each landmark interacts with each other. Here's the architecture and technical overview. We feed 467 facial key points into a 128D embedding layer, followed by a two-layer transformer encoding. Then we use global average pooling and dense layer to classify into 7 emotions. This model outperforms previous approaches. And this decision tree shows how is the thought process, why we used embeddings, attention layers, pooling methods. Each choice was based on maximizing the accuracy and preserving the spatial relationships in the facial data. The task 3, which is updates to the main website, we rampivered our main website to improve usability and reflect recent changes. We added new branch addresses, team member photos, and intuitive icon based on navigation. The homepage was refreshed and updated layout and content. These code snippets show how dramatically rendered therapy sessions with hover effects and linked icons, making it easier to users to navigate and connect with relevant services. The task 4 that we have worked on is image capture in games integration flow. So we integrated automatic image capture into our games. Every 2 seconds, the system captures a webcam image, sends it to backend, and stores it in the game type, by its game type. This lets us to analyze expressions during the gameplay. On the front end, a custom React hook handles time image capture and sends it via post. The backend saves the images with unique file names into organized folders. This design is non-blocking and scalable. So these are some of the code snippets which show auto capturing for every few seconds and uploading captured images to the backend, hook setup for image capture, and starting game with auto image capture setup. And these show hook setup for end capture. When the game ends, the capturing of images should also end. So this is the hook that is used to do. And serving the uploaded images as static files. This snippet shows that. And backend route to handle image uploads. So here is the quick demo of integrating the image capture to a previous game. So here you can see a start game button. When you click on the start game button, it redirects to the game page where you can play the game, and every 2 seconds behind images are being captured, and those images are sent to the backend and they are served as a static files. These files are stored in a particular folders, and this is how the game is. It's a simple game which is matching the images from the left side to the right side, and for every 2 seconds the images are being uploaded, which you can see here in the console. So these images are being stored in the backend in the form of static files in some folders. So as discussed earlier, when the child is playing the game, the images are captured and those images are stored in the backend as static files. So this is the backend folder, and here you can see a folder called as uploads. And inside uploads, we have all these images, and these are the images that are being captured in the front end and stored in the backend. So all these images are stored with unique numbers, and for every game, every 2 seconds the images are captured, and when the game ends, all these images are stored in this uploads folder. Coming to the task part, which is report generations. So why to automate reports? So we wanted to save therapist time and standardize assessments. Our system automates IQ report generation, accessing norm tables and dynamically calculating results based on the user inputs. Now I'm going to explain the workflow of the report generation. So the first step is the initial selection. The therapist is going to choose the report type. It can be MISIC, BKT, or educational. So in case of MISIC, We have interface tab interface unit where we have different tabs for taking inputs from the user. Like in tab 1, we take personal details. In tab 2, we take the educational scores of spelling and reading. And tab 3 and 4, we take the verbal and performance test raw scores. And in tab 5, recommendations. After all the inputs are given, and then the IQ scores respective to the ages are dynamically calculated when they hit on the submit button. After that, the data is stored locally across all the sites. Full report is compiled and it's available to the user in the on the preview screen. And after that, the data which is entered by the user and the data which is calculated according to the ages is saved to the database, and the document will be available to download. These are the code snippets explaining how the data is stored locally and the front end side, get request to the back end from the front end, and the JSON file for the norm tables with respect to the ages, section and name. Like here it is age 10, section verbal, and name is arithmetic. According to that, the norm tables are available in the JSON files. And then these snippets show how fetch and update of TQ scores is happening, handling get request, mapping the scores backend. Now it's time for a quick demo again. This form is used for report generation. As you can see, all the child data is already pre-filled. When you click save, the data gets stored. In the third tab, you can view the TQ scores. These TQ scores are automatically calculated based on the raw scores, which are displayed here. As demonstrated, when the raw score is changed, the corresponding TQ score also updates automatically. Similarly, the next tab contains the performance text section, and in the final tab, we have the recommendations. After clicking save, you can submit the form and the data will be stored locally. And finally, we have filed a patent for our emotion tracking system. It combines 3D face mesh and transformer-based model to detect emotions, even in poor lighting or occlusion. Our innovation lies in data filtering, facial representation, and real-time interface. The patent titled A System and Method for Expression-Based Emotion Detection has been filed with Indian Patent Office. It's currently pending approval, and we are hopeful about its impact and emotion-aware applications. So these are some pictures of our application details and the about the patent tag, our application form. And that concludes our presentation. These were the tasks that we did till now, and we plan to work on report generation in future. Thank you for your time.